Hey friends, in this video what we're going to do is we're going to look at the properties of quadratic functions, and we want to focus a little bit in on how do we start to figure out some of the important parts of our graph. So the properties like the vertex, the axis of symmetry, the max and the min, without having to use our graphing calculator all the time. Now it's really nice that we have our graphing calculator, but we're not always going to be able to, depending on the situation, use our graphing calculator. So let's take a peek right here. So we're going to try to do a little bit more algebraically today. We'll still do some graphing today. So make sure you got that graphing calculator. All right, first one, a parabola, which is the graph of a quadratic, passes through the coordinates 2, 0 and negative 10, 0. Determine algebraically, so that word again bolded, determine means you better show me some work, the axis of symmetry. Okay, first thing I'm going to do, it's always nice to have a pretty picture, right? Now, what do we got here? We've got coordinates 2, 0. So let's say it's here. There's 2, 0 and negative 10. And it says we have a parabola passing through this. Now, I don't know which way this parabola is going, up or down. It does not matter. I'll just go up because it looks like a smiley face. Why not, right? Okay, it's not perfect, but there's my parabola, f at x. Okay, so how do I find that axis of symmetry? So remember, the axis of symmetry is that imaginary line right there that cuts our graph in half, and it passes through the vertex. So how am I going to find that? Well, here's what we're going to do. Look at these 2 points that I was given. They're on the same horizontal line right here. The axis of symmetry is dead in the middle of these 2 horizontal points. So dead in the middle. Another way to say that is the average, right? And I've been finding an average since I was a little guy. I add my 2 things together, and then I divide. And in this case, I'm only going to divide by 2 because there's only 2 things. So my axis of symmetry, I like to think of as an average, because in some sense it is. It's the average of those 2 horizontal points. So I'm going to say x is equal to, because it's a vertical line, I add these things together, 2 plus negative 10 divided by 2. What does that sound like to me? That sounds like negative 8 over 2. And that sounds like negative 4. So to find the axis of symmetry when you're going between 2 points, I want you to think that's the same as finding the average of 2 horizontal points. Not bad, hey? Okay, so I like to say average, average, average. Like I said, we've been doing this forever. So let's just do another one for giggles. So a parabola passes through 6, 2 and 22. So I notice again, the y values are the same. That means these are horizontal. They're on the same line. So if I want the axis of symmetry, I add them together, the x values, and the order doesn't matter. So 20 plus 6 divided by 2, that's 26 over 2. And there we go. X is 13. There it is. Now, that's my axis of symmetry. Remember, the axis of symmetry is 1/2 of your vertex. So for my vertex right now, I know the x value is 13. The y value is still an unknown. And we'll talk about how do we find that y value later on. But that will be a very important question when we get to it. Okay, so we found at least one property of our quadratic function, the parabola graph, algebraically. Okay, nothing major in this lesson. In the next lesson, we'll do some more to find more algebraically. Okay, so a formula, if you really want a formula, well, again, what you're going to do is you're going to take an average. So you're going to use these 2 x coordinates, and you're going to divide them by 2. That's your axis. Okay? But what I want you to think is, hey, how could we do this if we were graphing something? Well, remember, our graphing calculator does pretty much everything for us, but only when we're given the actual function. So this one here says the height of a tennis ball that's thrown from the top of a cliff is measured in seconds in time, and it's modeled by this. Okay, so there it is. Something being thrown will always be a quadratic. And it says, okay, let's determine the maximum height the ball reaches. Where would you look at the vertex, the X or Y coordinate? Okay, so again, our vertex is an X and a Y. Remember, the X is the axis, and the Y gives us our max or our min. Okay, well, how are we going to find this? Well, we don't have the algebraic skills yet. We'll do that in the next couple lessons. So for now, all I want us to do is to go and put that thing into our calculator. So I want you to hit pause. I want you to graph that, and let's see if you can find the maximum. So you should have put this thing into your graphing calculator. And we go ahead and we hit graph. And there's what I see. And I've got y2 is equal to 0 there. You can see that. Okay, but I'm not really happy with the graph that I've got for a couple of reasons. I can't see the maximum. And friends, if this is something being thrown up in the air, the x-axis is time and the y-axis is height above ground. We need to change our window settings. It doesn't make sense. So I'd go to window. If x is time, the smallest amount of time I can ever have is 0. X max, well, that was pretty good. I could see where the graph would hit the ground. So I'm going to leave that, and I'll leave my scale alone. Y is height above ground. So I'm going to change that to a 0, because that's the lowest height above ground I can ever have. Max, well, I couldn't quite see the max. So I'm going to guess. I'm going to go 15. And I'm going to maybe make my scale bigger. There it is. So now let's try this. Hit graph. That's a much nicer picture. And if I wanted to, on my X value, my X max, I could zoom in to maybe 5 if I wanted to. There it is. Okay, so if we wanted the maximum value, the maximum height this rock goes to, second, trace, max. And again, remember on the TI, you got to do this left bound, right bound stuff. So the first thing I got to do is find my cursor because it doesn't automatically pop up. There it is. Okay. And just hold it down until it's to the left anywhere. Enter. To the right. Enter. Who cares? Guess. There it is. So your maximum value would be at 13.8. What does the 0.6 tell us? So our vertex is 0.6, 13.8. What does that tell us? So we're at 0.6, 13.8. Well, this is our maximum height of our rock. Or no, it's not a rock, it's a ball. I don't know why I switched to rock all of a sudden. Okay. What is that though? That's an important piece. What is that? Okay, let's talk about it. Look at number 2. To determine the time it takes the ball to reach its maximum height, we would look at the vertex, but we would look at the x coordinate. This value of 0.6 and 13.8, what that 0.6 is it's the time it takes to get to the max. Time it takes to get to the max, to reach the max, whatever it is you want to say. Okay, so don't ever just ignore that x value. That's actually really important. We've seen almost this exact question on a 30-2 diploma. Okay. Number 3, to determine the time the ball is in the air, which part of the graph would you look at? Okay, so I'm going to go back to our graph. Well, how long is the ball in the air? Well, if the blue is the path of the ball, when it hits the ground on that red line I've got drawn there, that's where that is going to stop. It's going to hit the ground there. So to find that, I go second, trace, intersect, first curve, second curve, guess, intersection, and we'll round that to the nearest tenth. We'll say 2.3. So where did we look? We looked at the x-intercept, and more importantly, I'm going to say the positive x-intercept, because this graph really has 2 x-intercepts. Okay, so we're going to say the positive x-intercept, and we always write intercepts as coordinate pairs. So it would take 2.3 seconds. All right. to determine the initial height of the ball was thrown from, where would I look? Well, that's when time is 0. So I go back to my graph. Where was time 0? Time is 0. Well, look at that's the y-intercept. So again, I can hit trace to go back to that point, or another way I could do it is go second calc value and let x equal 0. It's at 12. So where do we look for the initial or beginning amount? We look when time is 0, because what we really want is the y-intercept. And so that's the point 0, 12. So that was the height the rock was thrown from, I should say. Okay, that's also, my friends, the constant term in the equation. So that's helpful to know too. So there we go. There's some important information, isn't it? Right? So today, you're going to work on finding the axis of symmetry algebraically and then using your graphing calculator to find other parts. In the next lessons coming up, we'll find the x-intercepts and some of the other, the max, the min, algebraically. So we're taking it a little slow for now. See you next time, friends.